Hi, ladies and gentlemen. It's time to do lab number 5, which is simply entitled tension. Now, tension is when we start putting a force on something and molecules start responding in the opposite direction. Notice I'm pulling down? Well, that tension is pulling up. What I have is a spring scale. A spring scale reads newtons on one side and it reads grams on the other side. So since tension is a force, we want to measure this in newtons. Grams is a mass. More on that later. The lab is set up in a very simple format. It wants you to add 100 grams each time and then read the spring scale to measure the tension. I'm going to start with 100 grams, just like the lab says, and then I've snapped a picture of what the spring scale reads, and that's at the bottom of this document you're looking at. I'm now going to put 200 grams on here. And then I've already snapped a picture of what the spring scale reads. I'm then going to add 300 grams. And yes, the tension is going up if you look at the spring scale going down and down and down and down and down and down. Finally, the last mass we're required to put on here is 400 grams. And what we want to do is every time we want to take these readings and put it on our data table that you're looking at where it says spring scale reading per hanging mass. The next task it would like us to do is it would like us to measure the weight. So I'm on step 6 now. It says, how do we figure out the calculated weight of each of those masses? Well, we're going to use the equation. The force of something's weight equals mass times gravity. So the mass has to be in kilograms, already converted on your data table for you, and then we're going to multiply it by 9.8. Those calculations go in the last column where it says calculated weight, and the units we're looking for are going to be newtons on that. That's the end of part 1. Finish your data table, answer your questions. If you want to push pause. But I'm now going to part 2. Part 2 wants to understand what the relationship between tension and angle of attachment is. So if I scroll to that part of your sheet, what we see is an image of 2 spring scales side by side. We'll call this one A, we'll call this one B to match the image on your worksheet. What we then need to do is we need to get angles of 0, 15, 30, 45, 60, and 75. And we would also like to make a graph of the angles compared to the force we read on the spring scales by hanging this 1 kilogram mass on here. So we are going to measure the angles in between. So there's 0 degrees in between these right now. I put my protractor here and I slide these apart so that I can measure 15 degrees. Well, what is the reading on the scale? Look at the bottom of this document. I've taken a picture for you. Now we're going to go to 30 degrees. And I'm going to measure from the vertical. This is 30 degrees from here to here. 30 degrees from here to here. Okay, that's 30 degrees. We look at the reading, we put it on our data table. We then move to 45 degrees. What's the tension doing? Is it going up? Is it going down? Is it staying the same? We're now going to go to 60 degrees. Take a look at the picture I provided. And then we're going to max, it's straining to do 75 degrees. Take a look at all of the pictures, place it into the data table, and then you can answer the questions. And then there's an algebra question which asks, what is the y equals kx squared relationship? In this lab, we need to consult our big 4 equations that we learned when we were doing our Excel graphs. So you need to pick which one of these big 4 you think matches this lab. If you have any questions, hit me up in an email, answer all of the questions on this lab, and then upload it into Cami for me. Thanks for watching.